Gaze up at the night sky. What do you see? Stars, planets, and the soft glow of the Milky Way stretching across the sky. But have you ever wondered how many other civilizations could be out there, staring back at us? Today we're exploring one of humanity's greatest questions ever. How many civilizations could be living in the Milky Way? To approach this question, we must begin with the Drake equation. In 1961, astrophysicist Frank Drake created this equation as a means to estimate the number of communicative, active civilizations in our galaxy. The Drake equation is as follows. N equals R multiplied by Fp multiplied by Ne multiplied by Fl multiplied by Phi multiplied by Fc multiplied by L, and each variable represents N equals the number of civilizations in the Milky Way, R equals the rate of star formation in the Milky Way, Fp equals the proportion of those stars which have planetary systems, E and under, the number of planets which can harbor life per star, if L equals the proportion of those planets on which life actually emerges, Phi equals the proportion of life-harboring planets on which intelligent life emerges, Fc equals the proportion of civilizations which develop detectable technology, L equals the time over which such civilizations emit detectable signals. By inserting estimates for each of these variables, we can estimate the number of civilizations out there. But that's the catch. Many of these variables are unknown. So let's look at what we do know and don't know. Let's start with the first two variables, rate of star formation and the fraction of those stars with planetary systems. We do know that stars are constantly forming in the Milky Way. Current estimates are 1 to 3 stars formed per year. And thanks to missions like NASA's Kepler Space Telescope, we now know most stars have planets. In fact, it's now estimated 80 to 100% of stars have planetary systems. So if we use the lower estimate 1 star per year and assume 80% of those stars have planets, we're already speaking of hundreds of billions of planets in the Milky Way. That's a heck of a lot of real estate for life. Coming next is the average number of potentially life-supporting planets per star. This is where we have the idea of the habitable zone. It's the area around a star where temperatures are perfect for liquid water to survive, a main ingredient for life as we know it. According to existing statistics, researchers believe that 20 to 50% of stars have 1 or more planets in their habitable zone. That would mean tens of billions of potentially habitable planets in the Milky Way galaxy alone. But here's where it gets complicated. Just because a planet is in the habitable zone, it doesn't necessarily mean that life will evolve there. That leads us to the fraction of those planets where life actually developed. On our planet, life occurred relatively quickly after the planet was formed. But we have no idea if this is typical. Is life a cosmic accident, or is it nearly guaranteed to occur if the right environment is present? We're still arguing about it, but some estimates place life at anywhere from 10% to 100%. And even if life does occur, is it likely to develop into intelligent life? That's the ratio of planets with life on which intelligent life develops. On our planet, intelligent life took billions of years to develop, but we have no idea if this is typical or an unusual occurrence. Assuming intelligent life exists, the question is, do they develop technology that we can detect? This is the fraction of civilizations that develop technology we can detect. On our planet, we have only been sending radio signals for a century. If others are similar, their detectable signals would only be temporary. Finally, there's the time that such civilizations send detectable signals. The duration of a communicative civilization. Do they self-destruct, or do they survive for millions of years? This is perhaps the most speculative parameter of all. So what does the Drake equation really say? On the optimistic assumptions, we might have thousands or millions of civilizations in the Milky Way. Or on the pessimistic ones, we might be discussing only 1, ours.